So our first multiple choice question is this. You record the age, marital status, and earned income of a sample of 1,463 women. The number and type of variables you have recorded is what? If you take a look at this, here are the variables we have. So there's going to be 3 variables in total. So basically, just with that alone, we are down to either A or E. Which, if it's a quantitative, means you can compute the average and it would make sense. So we could compute the average of earned income. We couldn't of marital status, so this is going to be categorical. And age, we could actually compute the average and it would make sense. Therefore, for that one, D is the right answer. Another thing to keep in mind is categorical is something where you would give more of a word answer. Or if it was a numerical answer, taking the average would not make sense. For example, asking someone's zip code. It's a number, however, an average of it makes no sense. Therefore, that would be categorical. Question 2. Consumers Union measured the gas mileage in miles per gallon of 38 vehicles from the same model year on a special test track. The pie chart provides information about the country of manufacture of the model cars tested by Consumer Union. Based on the pie chart, we can conclude what? The correct answer for this problem was letter E. Now, the one thing about a pie chart, it tells you the whole story. We can clearly see here that the U.S. has over half of that circle. Therefore, more than half of the cars in the study were from the U.S. Does make sense. Letter D doesn't hold because we don't see anything about the types of cars that were in there. Letter C on this one doesn't really show us anything about the gas mileage. This is here showing us just the count distribution. B, the higher the gas mileage the cars are from other countries, we can't tell that either because this is just representing all 38 cars in terms of their counts of the cars. And then A, the Japanese cars get significantly lower gas mileage than others. We can't tell based on this chart at all. For question 3, referencing back to that pie chart on the question 2, which of the following bar graphs is equivalent to the pie chart in question 2? The correct answer here was going to be letter B. The one thing we know about the pie chart is it represented all 38 of the cars that were tested. So if we look at these bar graphs, not histograms, because histograms would be touching and showing frequency, these are bar graphs, the total of all of these bars that we have here would have to add up to 38, so that would be graph B. Question 4. Earthquake intensities are measured by a device called a seismogram, which is designed to be most sensitive to earthquakes with intensities between 4.0 and 9.0 on the Richter scale. Measurements of 9 earthquakes gave the following readings. So here we have them. We see that 3 of them we don't have the numbers for. L indicates that the earthquake had an intensity below 4.0, and H indicates that the earthquake had an intensity above 9.0. The median earthquake intensity of the sample is what? The correct answer here is going to be letter B. To find the correct one, what you're going to want to do is to put these numbers in order. Even though we don't have numbers for L and H, we can put them in a placement, which would look like this. So if we put them in increasing order, we now actually can go through and find the median. So I'm going to cross off maybe 3 on this end and then 3 on this end. I'm going to go for another, and therefore 6.0 has to be in the middle. Here's question 5 and 6. In a statistics class with 136 students, the professor records how much money in dollars each student has in his or her possession during the first class of the semester. The histogram shows the data that were collected. Notice this histogram right here is a frequency histogram. It's counts. If it was percentages, that would be a relative frequency histogram. Question 5. The percent of students with less than $10 in their possession is closest to, and the answer here is going to be letter C. Easiest way to go about that, we went less than $10, so we know that's just going to be this first bin. That is 60 students out of the 136 students, which comes out to be about 44%. So based on our choices, C does make the most sense. Question 6. Which of the following statements about this distribution is not correct? The correct answer here was letter C. And let's go ahead and look at the other options though. Letter A, the histogram is skewed right. What you do, remember, is you follow the tail, so this is skewed right. That's correct. The median is less than $20. What we know is that If we have 136 students, the middle number, if we take 136 divided by 2, is going to be the 68th student. We know that this first bin has 60 students, so we only need 8 more, which are somewhere in this bin. The median, therefore, does have to be less than 20. It's somewhere in the second bin, and I don't know if what the answers were between 10 and 20, but it was less than 20, so that is also correct. Letter D, the mean is greater than the median. Because this distribution is skewed right, we know that the outliers in this case are going to pull the mean more to the skewed side of it, which is to the right. So if the mean is pulled more to the right, the mean is going to get larger and the median is going to be smaller. So D is correct. And then letter E, the histogram is unimodal. There is one hump on this histogram, so therefore we would say is unimodal. The IQR is 35. The reason that that is incorrect is if we wanted to compute the IQR, remember that's going to be Q3 minus Q1. So Q1 is the 25th percentile. So of 136 students, if I want who's at the 25th percent, I'm looking for the 34th student. The 34th student sits somewhere between bin answer of 0 and 10. I don't know exactly what their answer was, but somewhere between 0 and 10. Now Q3 would be the 75th student, so I'm going to take 136 times 75%. That would be the 102nd student. So if I look for the 102nd student, what I know is our first bin is 60. This is 40, so I'm now at 100. The 102nd one is going to sit somewhere in this bin here, the third one, and that bin is between 20 and 30. I don't even know the answers of what the responses were within the bins for the people, but worst case, if I were to take the 30 of our Q3, or the highest end I should say, and the 10 of this one, the difference would be 20 at the most. Therefore, this is not an adequate answer. Overall, it's hard to get an exact IQR from a histogram. We would definitely want to get that more from a box plot if we could, or to compute it directly from all of the raw data. Question 7. 40 students took a statistics exam having a maximum of 50 points. The score distribution is given in the following stem and leaf plot. The third quartile of the score distribution is equal to what? Well, here's what we know. There were 40 students, and we want to have the third quartile. The third quartile is the 75th percent. So I'm going to take 40 times 75%. That is going to give me the 30th student. So what I want to do is start from the bottom and count upward and find the 30th student. Be very careful when you do this. Remember, in this stem plot, the more bottom one here is going to be the 2 and then the 8. So if we count up to 30, we're going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. What I landed on was this actual second 4. So the third quartile is going to be at the number 44. Question 8. The mean salary of all female workers is $35,000. The mean salary of all male workers is $41,000. What must be true about the mean salary of all the workers? Now your best answer, I should say the correct answer here, is actually going to be letter C. One of the things that's difficult about this problem is we do not know the count of how many females there were and how many males there were. If we knew the counts, we could do a lot more investigation with these numbers. The only thing we can say is that it could be anything between 35 and 41. We know that because they're not going to go lower than 35 because the men are higher. So when you average these out, again, we can't get a good average as it is, but we know it's somewhere between the low end and the high end. Letter E is not valid. It actually could be larger than 40,000. What if there was only one female and there were 100 men? If you computed an average, it's definitely going to be over probably the 40,000. It must be larger than 38. We don't know that. What if there was 100 women and 1 male? Then it would go more towards the lower end. B, it must be larger than the median salary. We don't know this either. We don't know the shape of the distribution. If the shape of the distribution is somewhat symmetric or approximately symmetric, the mean and the median could actually be fairly close to the same answer. So we don't know enough information to get that. In letter A, it must be 38,000. We have no clue again because we don't know the counts of the men and the women themselves. Question 9 and 10. A survey was designed to study how business operations vary according to their size. Companies were classified as small, medium, or large. Questionnaires were sent to 200 randomly selected businesses of each size. Since not all questionnaires in the survey of this type are returned, researchers decided to investigate the relationship between the response rate and the size of the business. The data are given in the following two-way table. So it's a two-way table because we have two variables. We have the size and the response that was given. You're going to notice, just take a look, here's all 200 of the small companies, the medium, and the large. We have a total of 600 surveys that were sent out. How many of them were responded and how many they got no response? So question 9, what percent of all small companies receiving questionnaires responded? Now you need to decide, is this more of a contingency question, which would mean we're just looking at maybe certain columns or certain rows, or is it all of the data? Do we look at all 600? In this case, when you read it, hopefully it makes sense to you that they're saying this. What percent of the small companies, so I'm going to go in here, that's my group. It's contingency, it's the small companies, so it's all out of 200. Of those did actually respond, that would be 125. You compute this, you're going to get 62.5%. Now this doesn't hold for every time you see a two-way table, but better than not. In most cases, when you first read it, careful how you read it, this is the group they're talking about. So I know it's just the small companies. I stop and circle them, and I'm isolating it just to this small group now and not all 600 companies in the table. Question 10. Which of the following conclusions seems to be supported by the data? The best answer here is going to be letter B. Let's talk about how we get to that. Letter A, there are more small companies than large companies in the survey. There's exactly 200 of each, so that doesn't make valid sense. Letter C, exactly the same number of companies responded as didn't respond. To me, this question is almost vague because I don't know, are you talking about by each size of group or what for that one? So they didn't give me enough information on that, but that's not a true fact either. The same count did not respond from both of the different sizes or all three of the different sizes. So not that one. Letter D, small companies dislike larger companies. I have no idea. That's not what they were even asked. It doesn't relate to the question at all. Letter E, if we combine the median and large companies, then their response rate would be equal to that of the small companies. Let's check that out. Well, the small companies' response rate would be the 125 over the 200, which we actually already calculated above at 62.5%. So now let's combine the large and the medium companies, so that's 400 in total. Their response rate would have been this total of 121. We can tell that these two are not the same percentages, so just double check it if you're not sure, but it can't be that. By default, it's B, but let's double check. Smaller companies appear to have higher response rates than medium or big. Well, we know the small company is 62.5%. If we do the median, it's going to be 81 over 200. The large would be 40 over 200. If you calculate those are clearly going to be smaller than 62.5. Therefore, letter B is our correct answer. Number 11. An experiment was conducted to investigate the effect of a new weed killer to prevent weed growth in onion crops. Two chemicals were used, the standard weed killer, letter C, and the new chemical, letter W. Both chemicals were tested at high and low concentrations on a total of 50 test plots. The percent of weeds that grew in each plot was recorded. Here are some box plots of the results. Which of the following is not a correct statement about the result of this experiment? So remember here, C is the standard weed killer, low concentration. Here's C, standard weed killer, high concentration. W is the new chemical with its various levels of concentrations. And our percent of growth we see right here. Just to make note, you can tell here we did have 3 outliers, it looks like, with the new weed killer at high concentrations. The correct answer for this one is going to be letter D. Let's talk about why the other ones don't work to help us kind of whittle down to why it's D. Part A here says, at both high and low concentrations, the new chemical W gives better weed control than the standard weed killer C. Now remember, we also want to know which is not the correct statement. If we take a look at this here, be careful, this is percent of weed growth. So for this one to be better control, we want a smaller number. If we look at the low concentration of the new weed killer, we're at about 25%. If we look at the low concentration of the current one, we're at about 35. So yes, it was better here. How about a high concentration? At a high concentration, that new weed killer was maybe at 18%, and as its median, the old weed killer was at about maybe 22, 23% at its median. So based on that, I would say A is probably a fairly accurate statement. It's true, and we want the one that's not, so it can't be A. B, fewer weeds grew at higher concentration of both chemicals. So if we look at the first chemical, the newer, which is W to W, here's low concentration and high concentration. At the low concentration, our maximum is at 40%, and then below on this one for the box plot. At a higher concentration, the true maximum is actually here at 50, but it's considered an outlier. So I would look at here where the whisker ends at more 38. So it does look like at the higher levels it could be the case. Let's look at the median. The median of low concentrations at about, let's say 24%, and the median at the high concentrations at about 18. So that does seem like somewhat of a valid statement for the new chemical. How about the old chemical? The older chemical, the median of the lower concentration was about 35, and then the higher concentration was about 22. We can tell the maximum by far supports that to be a true conclusion. Therefore, we would say it can't be letter B. Letter C, the result for the standard weed killer are less variable than those for the new. So let's look at the complete spread between the max and the min to actually see the variability. Now the standard weed killer again is C, so we're going from about here to here is our variability. And then here is, again, our standard weed killer. This is kind of a lower variability also. This says the results for the standard are less variable than for those of the new. Again, the standard's kind of a short variability or length, short here. Clearly, by far, much more variability with the new chemical. So this would be true. We see less variability with that standard chemical. Letter E. Some of the results for the low concentration of weed killer W show fewer weeds growing than some of the results for the higher concentration of W. Now for this one, if you were to compare, again, we're just looking at the W, low concentration to high. If we look at the max, we can tell this result here is higher. This one is lower for the high concentration. For quartile 3, again, it's higher compared to this. For the median, it's higher. For quartile 1, it's higher. But for our minimum, the actual minimum does hold. It is true, and it says some of the results. Technically, for one of the results that we see in the box plot, we can't see all the other data elements in here, but this does have some truth to it because of the minimum, if you compare it, is actually a lower percent for the low concentration than on the higher concentration. Therefore, when we look at the final answer, it does have to be D. Let's talk about why. High and low concentrations of either chemical have approximately the same effect on weed growth. So if we look at letter C, for example, the older chemical, high and low concentrations of that, we're going to see that the spread on here for the low concentration is a little bit longer than the spread it is for the high concentration. We clearly see the median is it's down by 10%, so that's definitely not going to have the same effect for that. So for chemical C, I would say no, that's not a true statement. For chemical W, a low concentration, a lot of spread. For chemical W, the high concentration, we look more, this is the spread, because the problem with this box plot is it's going to be skewed to the right because of the outliers. So we would want to look more at the median, by the way, and the IQR for the measurements. You're going to notice that it does make a difference. The median here is high, the median here is lower. If you look at the IQR, because again, this is skewed to the right, we don't want to look at standard deviation or range. That's going to skew our results. You would want to look at IQR. The IQR is the distance we see in the box. That's about the same. It doesn't look too much different, but we clearly do see that the median did make a difference. So I would agree that they do not have about the same effects. D is a false answer. Let's look at number 12, our first free response. You're interested in how much time students spend on the internet each day. Here are the data on the time spent on the internet in minutes for a particular day reported by a random sample of 30 students at a large high school. Construct a histogram of these data. So what you want to do to construct your histogram is figure out the distance between the max and the min. The nice thing with these data, they're already in increasing order. So we're going to see the difference between 151 and 7. We have a range of about 144. Based on that, then, we want between 8 and 10 bins. That is a good, reasonable number. So to have between 8 and 10 bins, if the complete range is 144, if you were to take that and divide it by 8, you're going to get about 18 counts per bin. So maybe what we do is we have the bins count by 20s. We could start at 0, count by 20s, and go all the way up to 160. So let's go ahead and do something of that nature. So I've set this up where I'm going to have on the bottom here, I have my bin widths, and that's in minutes, so I should label it. And I'm going to have my frequency over here, and I'm going to count by 2s for my counting. If I go through and count, here's what I'm going to end up getting. Is something of this nature. Now, I just put the counts at the top to kind of show you that to make sure you could read it better. But this should tally up to be all 30 of the responses. Part B, are there any outliers? Justify your answer. We should just go ahead and do the outlier test. So you are going to want to know how to do that. So remember, in the high end, we're going to take Q3 and we're going to add 1.5 times the IQR. Anything higher than that number itself is fine, but anything higher than that number would be an outlier in the high end. For the low end, I'm going to take Q1 minus 1.5 times my IQR. Anything lower than that number would be an outlier in the low end. Remember, IQR is going to be Q3 minus Q1. So what I would do is you're going to put all this data into your calculator. From that, go ahead, do a one variable statistic on it, and get the value of Q1 and Q3 from the calculator. And what you should find is that Q3 is going to be 77 and Q1 is 30. So from that, we can compute our outlier calculations. So let's go ahead and do this for Q3. Would be 77 plus 1.5 times that IQR of 77 minus 30. Careful with your order of operations. Do the subtraction, then multiply here, add the 77 to that. And then we'll do on the low end, clearly for that one, it's just going to be the 30 minus the 1.5 times that IQR amount, which is the number 47. When we do that, we're going to get that the high end, anything at 147.5, anything above that is not good. And on the low end, what we're going to have is we actually get a negative number, which is fine. Anything lower than negative 40.5. So clearly that's not going to make any sense. Are there any outliers? In this case, we are going to find that there would be one then, the number 151. Last question. Would it be better to use the mean and standard deviation or the median and IQR to describe the center and the spread of this distribution? So to determine that, look at the shape. If it's somewhat symmetric, then we can be fine doing mean and standard deviation. If it's skewed right or skewed left, we need to use the median and the IQR. For shape on this one, we would clearly say it is somewhat skewed right. Therefore, we would want to use the median and the IQR. And ultimately, if you want a more detailed explanation why, because of the skewedness, there could be potential outliers, and what those are going to do is they are going to cause our median and standard deviation to be overinflated and not valid measurements for this skewed distribution. Number 13, a study among the Pima Indians of Arizona investigated the relationship between a mother's diabetic status and the appearance of birth defects in her children. The results appear in the two-way table below. Again, the two variables we have, because it's two-way, we have diabetic status, and then if were there any birth defects. Let's just take a look at what we see here. Here's the status for diabetic. There's 3 different choices. For birth defects, none or 1 or more. Part A, fill in the row and column totals in the margins. This is easy enough. We're just going to do the columns downward, the rows left and right, and these are the totals you will get that you see here in the table. Part B, compute percentages, the conditional distribution of birth defects for each diabetic status. So here's the key. Do they want us to compute the percentages by rows or by columns? That's what conditional is going to mean. So you have to do either rows or columns. In reading this, they want the distribution of birth defects for each diabetic status. So they want us to take a look at it per the diabetic status. So for this one, they are talking about the columns. So compute the percentages, and what you're going to get should be 100% in here, here, and here. If I do the percentages, what you're going to get for the first one, right here for the no birth defects non-diabetic is 96.1%. For the one below it would be 3.9%. That's 100%. Let me show you for the diabetic side now here. So for this percentage, you would get 80.9%, and then for this, 9 over 47 would be the 19.1%. Okay, part C, display the conditional distribution in a graph. Don't forget to label it. Well, here, this might be a good graph. If you just look at my initial setup, what I'm choosing to do is, because this is by 100%, 100%, 100%, I have each of those set up here. Now, I have the 2 responses, either none or 1 or more. None or 1 or more. We did compute percentages, so let's do that and label it as a percent. If I go ahead and put in the boxes or the bars, what you're going to notice, these 2 bars should be 100% in total, same as here and same as here, and this is what you're going to get. Something of this nature for a graph. Okay. Part D, comment on any clear associations you see. Now, as you look at this, remember, here's the status of the type of diabetes, if any, that the mother had, and then the birth defects found. You definitely see the same type of trend, with none very high. Here it's still very high. It is broken up a little bit more between the 80.9 and the 19.1. So to me, that's where I start to see kind of the one difference is the difference between these bar heights are really starting to get a little bit closer to each other, but we still have a similar trend. So overall, here's what I would say. There does appear to be an association. Non-diabetic and pre-diabetic appear to have babies with birth defects at about the same rate. So these birth defects here, about the same percentage. However, those with diabetes, this column, have a much higher rate of babies with birth defects. So we were comparing the 3.9% to the 19.1%. We definitely are seeing that our birth defect bars that we see here, we see a difference in the one where the mothers do have diabetes. Question 14. The back-to-back stem plot shows the lifetimes of several brand X and brand Y batteries. So here we have kind of a back-to-back. If we're looking at this, let's look at the key. 4-2 represents 420 hours. So careful, if we look at this for 1-7 for brand Y, that would be 170 minutes. So that's what we're seeing here. Here would be 220 minutes. Going backwards here, this 3-0 would be 300 minutes, so how we would read it. Question A, what is the longest that a battery lasted? We should see right here, the longest the battery lasted is going to be brand X at 550 hours. Question B, give a reason someone might prefer a brand X battery. Let's talk about question C also. Give a reason someone might prefer a brand Y battery. So let's give kind of a justification of what we're seeing here. Now, as you compare these two distributions, what we can see, we have brand X. If you look at brand X, by the way, we see here the spread. They're spread out between 300 minutes to 550 minutes. So their spread there is what, 250. If we look at the spread here, brand Y went from 500 to 170. So the spread there is 330. So brand Y has more spread or more variability. Then brand X has less spread, by the way. Then maybe when we want to find the median, if we count this, by the way, I see that there's 15 data elements here, and we're going to have 15 data elements here. So of the 15 batteries, if I want the one in the middle or the median, I would want to find the one at 7.5. So who's sitting between element 7 and element 8, basically? So if I count that, it'd be 1, 2, 3, 4, 5, 6, 7, 8. So the median is between 370 and 390. So take the average. 380 is my median here. The median here, 1, 2, 3, 4, 5, 6, 7, 8, is going to be at 430. So we're talking 430 versus what we said here was going to be our 380. So the median is going to be higher on brand Y. So the middle 50% has a higher brand life than Y, and X has a lower one, but Y had more spread than brand X. So with that, what could we give as a justification? Here's what I would say. For B, why would we choose battery X? The one thing about battery X that we do see is it has a higher minimum. So the higher minimum on this one for brand X is what's going to be the selling point. For brand C, what's going to be our selling point? I think the higher median. We came in here and said our median was at about 430, whereas on here our median was at 380. So that would be a good selling point. So when you're given these types of questions where they might say explain or compare, you really want to look for the things that kind of stick out. And I think that's what we're seeing here again was the median in the range or that minimum that came into play. Question 15. During the early part of the 1940 baseball season, many fans and players noticed that the number of home runs being hit seemed unusually large. Here are the data of the number of home runs hit by American League and National League teams in the early part of the 1994 season. Compare the distributions of home runs for the two leagues graphically and numerically. Write a few sentences summarizing the results. So let me tell you this. When they tell you to compare distributions, here's what you need to do. You need to talk about socks. You are expected at a minimum to talk about shape, center, and spread. If there's obvious outliers, bring it up. If there aren't any, you don't have to mention it. But you must compare those three components. So what we need to do is to find those components for the data. This problem is quite a bit of work. We're going to need to find the shape, the center, and the spread. So technically, you want to make a graph so we can see the shape. We want to put this data in the calculator, do a one variable stat so we can get some good measures of center and good measures of spread for this. Remember, if it's symmetric, let's look at the mean and the standard deviation. If it's skewed, we want to look at the IQR and the median. And then we want to make a good sentence about comparing it. Now I'm going to jot down some of the statistics that I got, and I'm going to make a box plot for comparison for this. So here's what I have. So here are the statistics from both using, again, one variable statistics from the calculator. Now I'm going to make a box plot to compare the shapes of these because I have some good statistics for it, and here's what this looks like. All right, here's our box plot. It's not the prettiest things on here, but it'll do. This is the box plot for the American League. The National League, we do see that there are two outliers in there. So if you are asked to construct a box plot at any point in time, because you have knowledge of the outlier test, you must do the outlier test. Here's what I would do. If you make a box plot on your calculator, when you put the data in there, when you choose the graph to do, choose the modified box plot. Always choose it. It's always going to tell you if there's outliers. It's a really quick way to do it. Okay, let's go ahead and compare the distributions. Now for the comparison part, I'm not going to write it down. You would have to. I'm just going to say it. Let's start with the shape. If we look at the shape, I would say that both distributions are reasonably symmetric. Because we know that though, folks, so now we know when we talk about center and spread, we can use mean and standard deviation, but we use the box plots just for the shape. So let's go into that now. I might say this: the American League has no outliers, but the teams that hit 29 and 31 home runs for the National League had outliers. So if there were outliers, state what they were. For center, we're going to talk about the median. So we could say for the National League, we see that the median is less than that for the American League. We might also point out here that all components of the 5-number summary in the National League are less than all 5 components of the 5-number summary in the American League. That's an interesting fact. Even though that's more than talking about the center, it is an interesting fact. We do know because they're symmetric, we should talk about the mean, so let's do that and say what we found. So we could say, in addition, the mean for the National League at 50.14 is less than that of the mean of the American League at 56.93. Now spread, let's talk about standard deviation, and we could just say there is more variability in the American League with a standard deviation of 12.69 compared to that of the National League with 11.13. And that's how you go about comparing two distributions. These aren't hard problems to do, but you need to make sure you talk about and compare things properly. It's very easy to forget part of your socks or not to compare American League to National League and bring in some numbers. It's a very time-consuming problem, but take your time if you encounter something like this because you can tackle it, but you have to be very thoughtful and cover all the points.